Bismillahirrahmanirrahim. Dear viewers, today we will design steel structure in Prota structure. So let's start. Close this one. Go to new. Right here steel structure. Click on OK. We will use VS Code import. First we will go for grid. Click on this. 4 meter span, 7 span, 4 meter, 4 span. Click on OK. Now we will go for insert story. We'll add additional to story. Click on OK. Here we can add another view 3D. Now go to window, tile vertical. Here this one we will make plan and this one we will make 3D view. Now go to building set out, edit story. Here this one 300 millimeter for pedestal height. This one 3 meter for a small office. This is eave height. Here foundation depth, for example 1500 millimeter, that means 1.5 meter. Click on OK. Now we are in eave height level, that means column top level. Now go to steel column. Here story 2, because this will reach at pedestal level. Then click on section. We will select UV member 356, 171, 67. This section we will rotate this one 90 degree. Here one, here one, here one, here one. We will change the section. We will take 457, 191 and 106. This section select, click on here 90 degree, click on OK. From here to, you just press the mouse at the left side, then hold and drag to the grid. Same from here to here. Now we will model beam, steel beam. Here in 3D it will be offset 1.5 meter. We can see here to here. See this, from this point to this point 1.5 meter. Now for this side to this side we have to change the offset. Here 1500, here it will be 0. So here to here you can see in 3D view. Now we will go to office level. Here we will draw another column. Here history will be 1, then section we will select 305, 165, 40, this one, same rotate, click on OK. Beam, section M305, 1 to 7, 37, click on this. Here in 3D we need to change it 0, update, click on OK. Now we will model secondary beams. Click on beam. Here beam in condition we will make pinned. Before it was fixed. Now select the section UB 152 or 127, smallest one. I'll choose now. Click on OK. Here it will show 0.25 L distance, 0.5 L, 0.75 and full distance. Here we can edit distance. After keeping cursor on this point, then press F2, 800 millimeter, then perpendicular like this, perpendicular. Now this is our secondary beams, and this is a small office area inside the steel shed. Now we will model stair inside the steel shed. Offset this side, press F2, minus 500 millimeter. Model a steel beam having section of, choose C section 275, 23. Select this one, click on OK. From here to here, same way, from here to here. Now we will see here, we will reverse this direction. This, click on properties, select, click on OK, update, and this support condition also will change. Same way, this and this properties. Here, from here also you can change the support condition. Fix, click on close. Now we can see the properties. This is fixed. this column we can move to this grid, and this one we can move to this one, we can move to this grid. Now we will model our beam. Now I will show how we will create a stair from these sections. Now select this section, this one and this one. Now these members will move to landing level. Right click, properties, go to right side, here DZ left, type -1500, press enter, then DZ right -1500, press enter, close. Now these sections are at mid landing level. Now this one and this one, we will go to properties, then left side -3000, press enter, and right side -1500, press enter, close this one. This is one small stair to go to the office level. Here this column top, we can go to properties, DZ top, here select, type -1500, press enter, close. In detailing time, we can model this stringer. For example, go to load Prota Steel, here if we click on this and this, then automatic stringers will be added, this like this. Here you can create area, clicking on this, select 4 beams, then right click, like this, click on this, then select the profile, this one, then right click, we can save this one. Now close. Now we will finish this modeling and analysis design. Now we will model pedestal for our columns. Go to pedestal level. Now click on this RCC column, 600 by 300, for example, here to here, then here, same way, from here to here. Now we will model bracing. This one, then select columns or members to create bracing. Here we can change our section 100, 75 or 100 by 100, 10. Select this one, click on OK. Here we can see we can create some offset here. Top left vertical 250, here top right vertical 250, same here, bottom also 250 and 250. Apply bottom to analysis. We will apply bottom to analysis and top to analysis, because we will consider this bracing effect for our analysis. Here some other options also: X brace, V brace, K brace. Click on OK. Select this, click on OK. Now we will model purlin. Go to purlins, then select this beam to this beam. We will choose this section by 4. Select this one, click on OK. We will choose 1 meter spacing. Here option for delete first member, last member. We will not delete that one. Perpendicular offset also I am not creating, so this one OK. Sag rod, profile hanger I will not use. Ridge rod I will not use. I will choose number 1, 10 mm dia rod. Use ridge rod. OK. Load, dead load. For load calculation I will use here 4 meter spacing, 7 number of span, and this direction also 4 meter. U height 6 meter, ridge height 7.5 meter. Okay, angle it is coming 10.62 degree. Beam length from column to ridge it is coming this one 8.14 meter. Purlin spacing 1 meter. Purlin number it is coming this. Area of one side of roof this is coming for this area, this length and this inclined width. Then length of purlin for one side of roof, total length this one. Now dead load as we consider 0.25 kilonewton per square meter and live load on roof 0.57 kilonewton per square meter. Now from here it will be automatically calculated as per the formula I have provided. Linear dead load on purlin 0.23 kilonewton per meter, linear live load on purlin 0.52 kilonewton per meter. So here I will provide load. Here G means dead load. So here add load, provide minus 0.23 kilonewton per meter and here select all, okay, select all, okay, load applied on purlin. And for live load, add load, here this one 0.52 minus 0.52. now select all, click OK. So our dead load and live load acting on the shade, roof shade, that will transfer to the purlin, and this purlin load will be automatically transferred to main rafters. So click on OK. Now our modeling finished. Now we can go for analysis. Go to first save the model. We can remove this grid view from our window. Go to this active window settings, scene settings, grid, click on OK. From here also scene settings, grid, click on OK. Now go to analysis, building analysis, parameters, steel design code, same this one. Here I will not use earthquake load. Foundation 200 kN per meter square, allowable bearing capacity of soil. Lateral loading, lateral drift, braced. Here we can provide title, click on OK. Loading combination, here load cases, here you can manually add load cases. Here loading generator, define dead load, live load, pattern load we will not use. Create unfactored Z plus Q, this one we can create. And here horizontal load combination, wind loading, this defines separate negative load cases also automatically, W plus X, W minus X, W plus Y, W minus Y. Now click on use different combination for steel member design. So we have to choose this one because there is steel member, concrete member also. So this one, click on OK. Now click on OK. Now we will define wind and story loads. Here wind load calculator, automatically we will generate wind loading. Here the directions, basic wind speed we will consider 160 km per hour. You can choose as per your region. Here converting that kilometer per hour to meter per second, it is coming almost 44 meter per second. Minimum wind pressure 0.65 as per the design code, and this you can edit. I am keeping by default. Here you can choose town or country. Include dynamic factors, here we will include this one. Category we will choose portal shade, this one, click on OK. category 3, click on apply, click on OK. Now here we can edit material, default materials for a steel column. You can choose this one, 355 steel beam, 355, and other members purling 235, 235, this 275, 75, brace also 75. Click on OK. Analysis, building model check. We can check the model if there is any warning. So no errors or warning. Close this. Now click on start. Close this one. Steel member design check. So finished. Now we can close this one. Go to steel design, check column design, all passed. Beam design, all passed. Only some beams failed for slenderness ratio KL by R factor. Close this one. In 3D view we can choose scene settings by design status. Click on OK. See all the members passed. For shortening this video, I have not applied loads on these members. Column section design. We select all bars. Close this one. Close. Now columns also designed. So our all the members passed. Now we can go for detailing. Now go to Prota Steel. Close this one. Now here you can see before we modeled these portions and other portions automatically updated. Now here we can add our connections. Once connection is this, like this. In this way we can change our view, line view like this, solid view. In this way you can change our view. You can remove grids from view. I will undo these connections. Now I will select whole model, then right click, IntelliConnect. From here we can create column beam connections. Here this one I will select. Next, this is next for column web to beam joint. We can select this one, simple one. Next, then run. Here see, these connections done. Now we can select, then right click, create purling connection. We can choose this one, angle type, reverse clit, this one. Next, this here we can provide offset, run, Done. Here you can see purlin connection created. So in this way we can design steel structure in Prota Structure, then we can export it in Prota Steel for detailing. For drawing generation, go for numbering, perform numbering, numbering complete, close this one. Now go to drawing, create part drawing, select this one. Okay. Now press F6, this one part drawing, double click, close this one. Here you can see the rafter part drawing. Close this one. Now select all, go to drawing, create assembly drawing, click OK. So finished. Now press F6 to see the drawings. Here we can see detailed drawings, and here bill of materials. So this is very fast and drawing presentation is very nice. Press F6. This one select and we can export as DXF file. Desktop, click on OK. Done. Close this one. We can see in AutoCAD. Open, go to desktop, this one, open. See here, these drawings are very nice to represent. So in this way we can design steel structure in Prota Structure, then we can do detailing in Prota Steel. So thanks for watching. Stay tuned for more upcoming important tutorials.
Press the bell icon on the YouTube app and never miss another update.